All right, so I think this is recording. All right, so let's take a look at number 3, see what we have here for number 3. We always check to see if there's any greatest common factor, and there doesn't look to be. Then I look to see if it's in standard form, and if there's any missing exponents, then I'm going to have to use zeros as placeholders, but it doesn't look like we have that. 4, 3, 2, 1 constant. Yeah, so now to use this rational zero theorem, we look to the constant term, this 135, and we write the factors of 135. So I need to come down and think about how 135 breaks down to a product of prime numbers so I can see what integers divide 135. So 5 definitely will. And 5 times 27 is 1, yeah. And then this breaks down to 3 times 3 times 3. So now as a product of prime numbers, I'll be able to figure out which numbers divide 135. Like I can see that 3 does. I can see that 5 does. I can see that 3 times 3 will get me a 9, so I know 9 divides it. 5 times 3 gets me a 15, so that'll divide it. And 3 times 3 times 3 is 27, so 27 will divide it. 9 times 5 is 45, so 45 divides it. And then that's it because, well, with the 135. So I believe that's all the factors that will divide 135. Now let's look at 4. I don't have to write the prime factorization of 4. I can just do it in my head. And I know that 1, 2, and 4. So these numbers are going to go in my numerator, and these in my denominator for this list. But I'm not going to write the entire list right now. I'm just going to create the list as I go and search for zeros, and hopefully I'll find what I'm looking for before I ever get to checking all of these possible values. So when we divide by 1, we'll get this list. So let's check positive and negative 1 and see if they're not zeros of the function. They might be, they might not be. So I'm doing number 3. So I'm always afraid when I shift my eyes over to write like this 32, when I come back, I'm always afraid I'm going to come back to the wrong problem, because I do that a lot, and it's getting worse as I get older and my eyes get worse. I guess you don't need to hear my problems. All right. So cross your fingers and hope that we get a 0. And it's not looking likely. Right, because this is going to be too, yeah, this is not going to give us a 0. Wow, that eraser's big. So let's try -1. Maybe it'll give us a 0. Maybe it won't. Maybe none of these. Maybe we'll be here all night doing synthetic division. That would be miserable. Wouldn't be hard, but it'd be extremely long. Doesn't look like this is hitting, yeah. All right, so much for 1 and -1. So the next number in the list would be 3 divided by 1. So we'll check positive and negative 3. So if we check 3, could it give us a 0? And definitely not, because this is getting up to 300. Yeah, there's no way. Even if I did a silly mistake and multiplied it, there's no way. All right, what about negative 3? Nope. It's not going to do it, right? Let's double check, but I don't think so. Negative 72 plus 27, and then times negative 3. Oh, hey, what do you know? I was wrong. See, that's why I use a calculator, and that's why I freely admit that I'm not good at mental arithmetic. I didn't think that was going to be a 0. All right, so we found one. Well, big deal, because that was a degree of 4, and this is now a degree of 3, and we've got to keep looking in the list. Now, it could be that this guy would have a multiplicity of 2, so let's check negative 3 again. Definitely not a 0. Okay, so it's not got multiplicity 2. All right, so we checked 3 and it didn't work. We just checked negative 3 and it did. So we're through with that. So now let's go to the next number in the list, 5 over 1. So let's check 5 and negative 5. All right, so let's check 5. So this comes down. That's not going to work. Because look how big that, yeah, that's not going to work. Let's check negative 5. Hey, hey, hey. We did it. It works. And now we're down to 3. We're down to a quadratic. All right. So even with this incredibly long list, and it would have been long if we would have, had to have written it out to keep writing it, we didn't have to go through and check the whole thing. We got lucky that the zeros were here close to the beginning where we started. I'm going to erase this over here and use this space. All right. So my function in number 3, I can factor it with a factor of x plus 3, with a factor of x plus 5, and now this guy, 4x squared, 0x, I don't need to write that, minus 9. Well, that's a difference of perfect squares. That's factoring a squared minus b squared to a plus b times a minus b. So we're ready to factor this completely. So this factors to 2x plus 3 and 2x minus 3. So the zeros of this function, it was a 4th degree, and we have found 4 zeros because negative 3 plus a positive 3 will give us a 0. Negative 5 plus a positive 5 will give us a 0. Subtract 3 and divide by 2. Add 3 and divide by 2. And so here we have it, our final answer. All right, I need to take a break and make a phone call, and I'll be back in a little bit with the last 3, 4, 5, and 6. All right, talk to you later. Bye.